Microsoft AI Business School. Implement AI in your organization. AI at scale. Executive Q&A. What innovations have been made in infrastructure with AI at scale? Luis Vargas, Microsoft, Partner Technical Advisor to CTO.
In the next 5 minutes, we'll talk about our progress on AI at scale, share how we're making our technology assets more broadly available, and look at a few examples of how we're using large models like Turing in our products. Let's start with infrastructure. The work that we have done on large-scale clusters and leading our design is making Azure better at supporting the AI needs of all of our customers, irrespective of their scale. Last month, we launched the private preview of AI supercomputing capabilities with the Azure NDB4 VM series, our most powerful VM series for AI. This is using the latest NVIDIA 100 GPUs and the fastest GPU-to-GPU interconnection. All this results in 3 times higher performance than with the previous series. Beyond this, the series can scale from 8 GPUs on one VM to tens, hundreds, or even thousands of interconnected GPUs in one cluster. Each GPU gets a dedicated 200 gigabit per second InfiniBand connection. That is 1.6 terabits per second of bandwidth per virtual machine, 16 times more than any other publicly available cloud offering. With regards to system software, to be able to use this infrastructure effectively, we continue innovating at a fast rate with DeepSpeed, or PyTorch library, to distribute and optimize the training of large models. This month, we open sourced the latest version of DeepSpeed, which further accelerates distributed training by 5 times through more efficient communication algorithms. In addition, by combining 3 times of training parallelism, data, model, and pipeline parallelism, DeepSpeed now enables training models way beyond the current limits, crossing 1 trillion parameters. In the coming months, we'll bring this innovation to the Onyx runtime, or framework-agnostic and hardware-agnostic runtime for AI, that brings together all of the innovation in Microsoft for training and inferencing of models.
What innovations in models have been made with AI at scale?
With regards to models, we continue evolving our Turing family of models, improving on their architecture, data, and size. Remember, these models have been trained on large amounts of web data to understand and generate language. They can be fine-tuned for any task involving language, from analyzing the sentiment in sentences, to answering questions, summarizing documents, and even generating product descriptions. Let me show you one example.
A printed page, sentiment analysis.
In this example, we'll fine-tune our Turing language model for a sentiment analysis task using the popular Stanford movie sentiment dataset.
Machine learning screens.
Using a Python notebook in Azure Machine Learning, we will create a workspace to work in, deploying just one virtual machine with 4 GPUs for this simple task. We'll load the Stanford dataset, and finally, run the fine-tuning of the Turing model for 15 epochs. After just a couple of hours, you can see state-of-the-art accuracy at 95%. Let's now evaluate the sentiment in some statements about movies. The model will return 1 for positive and 0 for negative. The first one, "This was worth spending 2 hours of my life," is a 1, means it's positive. The second one, "I would really love to have 2 hours of my life back," has a typo in back, but thanks to its language understanding, the model can still understand that the sentence has a negative sentiment, or 0. The next one, "The script for this movie was probably found in a hairball," is a complicated statement, but the model still understands it as negative. The next one has a slightly more complicated grammatical structure, but the model can predict its positive sentiment. For "This has a nice plot for a horror movie," the model understands that horror is the genre of the movie, but that the sentence has a positive sentiment. Unlike the next sentence, "This movie was a horror," where horror is used to describe the movie, and therefore the sentiment is negative.
How are Turing models being used in current applications?
At Microsoft, we're already using our Turing models behind many of our features in Bing, Office, and Dynamics. Let me show you a couple of examples.
Water quality report.
Bing has been using Turing for the past year to empower its search and question answering capabilities. Let's now look at how we have innovated the find feature in Word in the same way. Let's search for paragraphs related to the terms lead and water.
Search field at right.
Word finds 5 matches in the document. If I click on any of them, it'll send me to the relevant paragraph in the document. Even if I make a typo, where we'll find the relevant matches. This is very useful for complicated words. For example, cryptosporidium, something like that. Okay, so that's the one that I was trying to find. Now, Word can even answer questions about the document. For example, how often is water tested? And the answer is here, between 10 and 100 times per day. You can find information in the document. What about how to reduce lead in water? And the answer is here, to flush it through the tap until it's significantly colder before using it. We think of our large models and the infrastructure and systems that enable them as a new type of platform, one that enables faster innovation and better collaboration. We believe that this platform needs to benefit everyone, and so we'll continue making all of our tech assets more broadly available. We're very excited to see what you build with this.
Microsoft.